Introduced to substitution. If you watched the last video, which you probably didn't, but if you did, you will know that I introduced that in that video at the end of it anyway. So long story short, the book and I have a failure to sort of agree with what's going on here. I don't see equal values method as any different than substitution. Let's ignore this problem for a second. When you get something that looks like this, that's supposed to be y equals 3x plus 2, and y, oh good night, and y equals 5x plus 1. You're still substituting, in my opinion. You're saying, hey, look, this equals y and this equals y. I'm gonna get rid of this y, and I'm gonna replace it with this 3x plus 2 instead. That's how I see equal values methods. So the idea that substitution and equal values method are different, I just don't necessarily agree with, and I'll show you what I mean. In this example, they want us to go through the trouble of getting y by itself and then putting them together, and it's a big, nasty problem. But really, again, this is like a $10 bill, and this is two $5 bills. If you go to the grocery store and you give them a 10 and they give you two 5s, you don't like think that there's something wrong with the transaction. Like, that's just, they have the same value. So you can substitute for each other. So I can go into this equation right here and I can say, oh, you know what? I don't want a y because I don't want a y and an x. Instead, I want only x's. So I'm going to take this y out and I'm going to substitute it with this negative x minus 7. And then I'll just complete the equation. So if you look in the parenthesis, you can see the parenthesis is essentially these two being worth each other and me replacing one with the other. And now I only have one variable, and I can solve it if there's one variable. Again, I've said this several times, but here, this has infinite answers, but this only has one answer because this has two variables and this only has one. So that's supposed to be a 10, by the way. So if we look here, I can solve this by distributing the 5. Collecting like terms, and then I'll just add 35 to both sides while I'm at it. So I'll get negative 2x equals 22, divide by negative 2, x will equal negative 11. Now I can go up to either one of these. I'll go into this one. A negative 11 is 11, minus 7 is 4, so I get y equals 4. And then I'll go into this one and make sure I get the same thing. 5 times 4 is 20. Minus 33, well, 20 minus 33 is negative 13. So this ordered pair works in both lines. And don't forget, what we're really saying here is this first one, y equals negative 3x minus 7, is a line. And this 5y plus 3x equals negative 13 is a line. And they meet at this one point in the universe, and that one point in the universe happens to be negative 11, 4. So that's what we're getting when we do this problem. Now, if you look here at 656, it's actually discussing everything we just discussed. So let's go to 657. Bharat and Ingrid leave their school. They're building at the same time on their bikes and travel in opposite directions. Hey, we have ourselves a distance equals rate times problem. Bharat's speed is 12 kilometers per hour. Ingrid's speed is 14 kilometers per hour. So let's go ahead and make one for each of them. So we know Bharat has a rate of 12. We know Ingrid has a rate of 14. How long will it take till they're 78 kilometers apart? So the time we don't know, but we know that, let's say Bharat equals D for distance, right? We'll say he goes distance. Sorry, I got a little confused by what was going on here. Well, if we want to know how long till they're 78 kilometers apart, think about it. They go in different directions, and we want the whole thing to equal 78. Well, let's say Bharat went D of that. They said use B, but I'll just leave it as distance, right? How much is left for Ingrid? Well, Ingrid will have her distance must be this whole 78 minus the D that Bharat went. So we'll say it's 78 minus D. I hope that makes sense, right? if he went 50, she went 28. 78 minus 50 is 28, and 50 plus 28 is 78. If he went 8, she went 70. So you can just plug in different answers and see how this works. This is a really crucial thing that we need to understand how this works here. And now at this point, we sort of have these equations. I don't know if you can hear what's going on in my house right now. It is impossible to focus. There's like plates getting slammed around and all kinds of stuff going on right now. And I'm trying to do this problem and ignore it all. But I don't know if you can hear it, but I can, and it's distracting. So long story short, d equals 12t. So I'm going to go over here. I'm going to take out the d, and I'm going to replace it with 12t equals 14t. I'll add 12t to both sides. I get 78 is equal to 26t. Divide by 26. So 3 equals t. So time is 3 hours. So I can go in here. I know that Bharat went 36 kilometers. And I know that Ingrid, if I plug 3 in here, I get 42, right? If I subtract that, I get 42, was it 36 as well? I don't think so. So let's plug that in actually. 78 minus d equals 14 times 3. We already know that this is 36, right? D was 36, so I get 32 here. I'm sorry, I get 42 here, and I get 42 here. So it checks out. That went really poorly. Let me do that again. I apologize for that. So what I'm saying is this. I know d is 36, so I'm going to go into this equation. 78 minus d, well, d equals 36, equals 14 times 3, because I know t equals 3. 78 minus 36 is 42. 14 times 3 is 42, so that checks. I'm really happy with my answer. 3 hours and 36 kilometers for Bharat. And it looks like Ingrid would have went set 42 is what we're coming up with there. Alrighty. God dang it. I did not mean to do that either. So are we on 622 right now, I think? I just get a little wonky doing these things. I just pound them out and then I get confused. All right, so that was 657. So let's look at 658. 658 says, when me solved the system of equations below, she got 1/6. Without solving the systems, how can you tell if she's right? Well, we've been plugging them in all along. Plug in 1 for x and plug in 6 for y and see if you get the correct answer. 4 plus 18 is 22. That made sense. 1 minus 12 equals 0. That does not make sense. So this is incorrect. It doesn't ask us to solve what is correct, but it does want us to get used to plugging in. So make sure you substitute into both equations to get the correct one. All right, and check your answer. So let's go to 622b and finish this lesson off. So happy birthday. You've decided to give your best friend a bag of red and green marbles for his birthday. Quite a gift. Your friend likes green marbles better than red ones, so the bag has twice as many green marbles as red. The label on the bag says it contains 84 total marbles. How many green marbles are in the bag? Write in system of equations for this problem, then solve the system. So I don't like problems like this where it only tells you, we're going to make up 2 variables, but it only asks us to solve for one. We kind of have to guess what the other variable is. So we'll say G is green marbles. And I guess we'll say R is red marbles. And of course, these are the number of green and the number of red. All right, so it says your friend likes green marbles better. So if we double the red ones, we get the amount of green ones, right? Some people get a little bit confused on that. They think it should be 2G equals R, but if we double the green to equal the red, that would mean we had more reds. So we want to double the reds to get the greens so we have more greens, because this says there's more greens. And then we know if we add the greens plus the reds, it equals 84. So pretty simple. I will replace this G with 2R. Substitute, right? Substitute 2R for G plus R equals 84. 3R equals 84, which means that R should equal, if I divide both, 3 goes into 90 30 times, so that must be 28 red marbles. And then I can double that. 2 times 28 is 56, so G is 56 green. And the last thing I should do again is check 28 plus 56 should equal 84, and it does. So I feel pretty happy with my answer. I guess I should have put green over G equals 56 green marbles over here. I apologize for my handwriting. Hopefully you're listening. I'm writing on a stylus, plus I have bad handwriting to begin with. So, all right, Carter walked for a while at 3 miles per hour. So we have distance equals rate times time, but his rate is 3. And then continued his journey on a bus traveling 15 miles per hour. I don't even know. I probably should have read the problem first before I started doing all this. His time on the bus was twice as long as his time walking. So if we make this t, we can make this 2t, right? We're doubling the time here. How long did he ride on the bus if his total distance he covered was 66 miles? So again, if I want to make this 66 for the whole thing, right? 66 is the whole thing. Well, if this is the bus, right, and we'll call the bus D, well then what's left is 66 minus D, right? Because we've taken out D out of the 66, so what's left is 66 minus D. So that's going to be our distance. So we get these two equations. Obviously, this is going to be distance equals 30t. Let me go ahead and clear up some room here. I know that these can be a little bit tricky, so as always, if you get confused on a question, feel free to reach out and discuss it. But I want to go over here and just replace D with with 30t. I'll add 30 to both sides, so 66 equals 33t. So 2 equals t. So 2 hours. Here. So if we plug 2 in for t, we get 4. So his distance was 60 on the bus. 60 miles on the bus. And then if I plug t in here, I get 6. And then 66 minus 6 is 6, so we feel good about that. So his distance is 6 miles walking. And again, he was 4 hours on the bus because it's 2 times 2, and he was 2 hours walking. Hopefully you're with me on that. A lot going on here, but distance equals rate times time.